You can't get very far with most games without some player movement. As in, literally, the player can't move anywhere without it. So in this video, we'll create a solid third-person controller with both player and camera movement. Of course, just like with first-person controllers, how you want your movement is going to completely depend on your game. This of course raises a lot of questions, like do you want the rotation of your player to follow the camera? Do you want smooth or snappy movement? Should your player be able to strafe, run, jump, and so on? And depending on exactly what you need and how you answer these questions, your controller is going to look very different. So instead of doing something really complicated and specific to one thing, let's create a really solid base that works and that you can easily add more on top of. But first, this video is sponsored by Jason Wyman. Jason is an industry professional and he just created a new amazing course on game architecture. The course teaches you exactly how to structure your game and code in a professional manner, so you avoid all the headaches that you might run into when creating a bigger game. You'll learn everything from writing testable code, project structure management, advanced state machine development, and the list goes on. The most awesome part is that you will learn everything through building your own unique RPG where you get to build quest systems, learn about inventory management and interfaces, and even branching dialogue systems. New content is constantly being added and you get access to weekly live QA sessions with Jason himself, alongside with email support and a Discord channel where you can chat with your fellow students. So no more getting stuck on problems you just can't solve. So sign up using the link in the description. And actually, we're now launching our first ever hoodie on our merch store Line of Code. Isn't it pretty? And it's a brand new Brackeys logo design created by our awesome editor Thea. For the first week, there'll be a 20% discount on the hoodie, and for those of you who sign up for Jason's course, you'll receive a free hoodie as well. Alright, remember to stretch and warm up because we're gonna get moving. So as you can see, I'm here in Unity and I've gone ahead and set up this really quick example scene. And of course, the first thing that we want to add here is some kind of player character. You can of course use your own model if you want, but I'm just going to use some simple shapes in Unity for now. So let's go to the hierarchy here, let's right click, go 3D object, and I'm going to add in a cylinder. I'm going to hit reset on the transform here and place him somewhere in my level. I'm also just going to scale him up a bit on the X and Z, and let's make him a bit taller on the Y here. So something like 1.2 by 1.8 by 1.2. And we're not going to be needing the collider here since this is just going to act as our graphics. So let's go ahead and right click on our capsule collider and hit remove component. And this will definitely do for now. However, this gives no indication of what direction our player is currently facing. So let's go ahead and right click on this and create a quick cube object as well. And let's just scale this down to make it a bit smaller and place it somewhere in the front of our players so that we can see that this is the forward direction of our player. It's not pretty, but it will do for now. I'm also just going to add a quick red material, remove the box collider on our cube, and that's it for our graphics. Now let's take these objects here and place them under a parent object for our player. So let's right click, let's create an empty object, and let's first of all center this on our cylinder. So let's drag it under our cylinder, reset the position here, drag it out again, and then drag our cylinder under our new game object. We then rename our game object to something like third person player. There we go. This way we've separated all of our logic, which is going to sit on the player himself, and all of our graphics, which are currently under the cylinder. And so we could also rename our cylinder here to graphics. Alright, so we're now ready to create some movement. And I think it's a good idea that we start with the camera. For this, we'll be using Cinemachine, which is Unity's solution for creating interactive camera movement. It makes it really easy to set up pretty advanced camera behavior without writing any code. So let's go ahead and open up our window and let's go to the package manager. Here we need to select all packages and we can then search for Cinemachine. Simply click on it and go to the bottom to install and update. And once this is in your project, we can start using it. To do this, we go to the top under where it says Cinemachine, and here we can create all kinds of camera behavior. What we're going to be making is called a free look camera. So let's hit create free look camera. And as you can see, this creates a new game object with a free look camera component. As you can see, this is a separate object from our main camera. Let's go ahead and rename this to third person camera. And what this essentially is going to do is tell our main camera what to do. As you can see, our main camera now has a brain component, and it shows here that the current live camera is the new free look camera. This means that it will currently follow the directions of our freelook camera. So let's go ahead and set this up. The first thing that we want to do is have it follow around our player. So let's simply take our third person player and drag it into the follow slot. We also want to have it constantly look at our player. So let's take our player object and drag it into the look at slot. And right away, if we switch to our game view, we can see that our camera is currently looking directly at our player. Let's just go ahead and duck this to the side here so we can see what's happening. Now, of course, currently our camera is way too close to the player. So to adjust this, we need to go down under where it says orbits. Now, we can think of the camera as having 3 orbits that we blend between. In fact, we can actually see these in the scene view. There's one at the bottom, one in the middle, and one at the top. And this allows us to adjust camera settings depending on the height of the camera. For example, it normally works well to have the camera move closer to the player when it gets near the ground. So to do this, we can position the bottom rig here near the ground and give it a pretty small radius. So let's start with that. So let's go over here under our bottom rig. Let's decrease the height here so that we get close to the ground. And let's set the radius to something like 12. There we go. Let's then set the height of the middle rig to something like maybe 5. And the radius to something like 17. And we can see immediately that because our camera is currently on the middle orbit, it gets farther away from the player because we increased the radius. And for the height here, let's set that to something like 14 and give it a radius of 12. We also want to set the binding mode here from symbol follow to world space. This is because that for this controller, we don't want the camera to be influenced by the rotation of the character. Instead, we want the character to move in the direction of the camera. And so our camera shouldn't be bound to our player, but to the world space instead. Now we can go ahead and preview our camera settings by simply going up under axis control and changing the y-axis value. As you can see, this moves our camera up and down. And it seems that there's an obstacle in the way here, so let's just take our third person player and move it over so that we can see what's happening. Or we can just hit play and try it out using our mouse. And as you can see, our camera is moving in and out of the 3 different orbits. Awesome! Now, by default, this is going to be using the standard mouse input. You can change the input axis names here in case you want to use something else to control the camera. Or even change the Y and X values manually through script by leaving the input names blank. But in my case, I just want to use the mouse. You can also change the sensitivity here by adjusting the speed. I'm going to set this to 4 and decrease the acceleration time. And I'm also going to increase the speed on the X. I'm going to set this to 450. Finally, you can actually compose your shot for each orbit by going into the corresponding rig in the inspector. As you can see, we can adjust all these properties here for top, middle, and bottom rig. Or even simpler, if you turn on game window guides at the top, you control this using the guides in the game view. So right now I'm on the middle rig and I can go ahead and adjust dead zones and position the player wherever I want. Really cool. But for now, I just want this to stay in the center. Alright, so now that our camera is working, it's time to get the player moving. To do this, let's select our player, let's hit add component, and we're going to add in a character controller. I'm going to set the radius of this to something like 0.6, the height to 3.6, and that should give us a nice character controller collider. I'm also going to add another component here, and that is of course a third person movement script. This is a custom script that we're going to be writing. Let's double click it to open it up in Visual Studio. Now I'm going to go ahead and remove the start function here, and the first thing that we need is a reference to our character controller because we're going to be using that to move. So let's create a public character controller and let's call it controller. You can think of the character controller as the motor that drives our player. What we need to do is tell the motor where to go. Let's also create some kind of speed variable. Let's create a public float speed and let's default it to something like 6. Now with this, we can go into our update method, and the first thing that we want to do is gather some input. Now Unity is currently working on a new input system. The old one is still going to be working for quite a while, and that's what we're going to be using in this video. But if you're having issues, definitely check out our video on the new input system in case the old one is deprecated. Now I want to be able to move around using VAST and arrow keys. So let's go ahead and get some horizontal and vertical input. I'll write float horizontal. And let's set this equal to input.getAxis raw. We're going to be using the raw axis because we don't want any kind of input smoothing. We just want the raw input. And let's input in here the horizontal axis. Let's do the same thing with vertical. Again, input.getAxisRaw, and we'll input vertical. So as always, the horizontal axis is going to go between -1 and 1. It's going to be -1 if you press the A key or the left arrow key, and +1 if you press D or right arrow. And the same thing for vertical, but with the W and S keys or up and down arrows instead. We then go ahead and create a vector 3 here, which is going to store our direction. And we can set this equal to a new vector 3, where we first input our horizontal. We then input 0 for the y-axis, and then the vertical. And of course, the reason why we are doing it this way is that if we go into Unity, we want to move our character, if we have a look from the top here, on the X and Z axis, but we don't want to move it on the Y. And just to make sure that if we hold down 2 keys and go diagonally that we don't move faster, let's go ahead and normalize this. Then we can check if we are moving in any direction by going if direction.magnitude, so the length of our direction vector, is greater than or equal to 0.1. Well, in that case, we're getting some input to move. And we can actually go ahead and move our character by simply going controller.move. Here we'll input the direction. We'll multiply with speed and multiply with time.delta time in order to make it frame rate independent. And if we save this and go into Unity, we now need to drag in our character controller here. We can set the speed to whatever we want, and if we play, we can start moving in the different directions. Awesome! As you can see, this is currently completely independent of where our camera is pointing, so we definitely need to have it orient towards the camera. And also, our player currently isn't rotating to face the direction that he's currently traveling. To fix this, let's first point our player towards the direction that he's moving. To do this, we need to take the direction and figure out how much we should rotate our player on the y-axis to point in that direction. And we do that using the atan2 function. So we'll create a float called targetAngle and set it equal to mathf.atan2. And here we'll input direction.x, direction.y. Now, what is atan2? Well, atan2 is a mathematical function that returns the angle between the x-axis and a vector starting at 0 and terminating at x, y. Now that might sound pretty complicated, but in reality it's actually fairly simple if we just visualize it. So here's a coordinate system. This represents our scene seen from above with our player in the center. The dotted line here is the direction we would like our player to point in. We can use the atan2 function, giving it first the y and then the x coordinate of our direction to get the angle from the x-axis to the vector. However, this assumes that our rotation starts at 0 at the x-axis and then increases counterclockwise. But in Unity, our character will have a rotation of 0 when he's pointing forward, and from here it increases clockwise. To take this into account, we simply pass in the x first, then the y coordinate, and voila, we have the angle we need. And if we have a look at our script, that's exactly what we've done. We take the atan2 function, pass in the x coordinate, and then the y coordinate of our direction. Now this will give us an angle in radians, so let's just go ahead and multiply this with mathf.radians 2 degrees in order to convert it into degrees. And now we have the angle that we want to use. So let's set our rotation by going transform.rotation equal to quaternion.euler, and this allows us to input 3 numbers, the rotation around our x, y, and z. So let's put 0. Around our y, we'll use the target angle, and around the z, we'll use 0 as well. And whoops, it looks like we used the direction.y here. That's of course 0. Instead, we need to use the z-axis here. There we go. And right away, we see that our player rotates to face the direction that he's traveling. Of course, he currently snaps really quickly into place. Let's just go ahead and add some smoothing to this. Let's create a variable to adjust this called public float, turn smooth time, and set it equal to something like 0.1 by default. And for this, we can use a function called the smooth damp angle. So down here, before we apply our rotation, let's create another float called angle and set it equal to mathf.smoothDampAngle. Here we input our current angle, which is transform.eulerangles.y, our target angle, which is our target angle variable, and then we need to give it a reference to a variable that can hold our current smooth velocity. And this is just a private variable that we create at the top here. So let's create a float, turn smooth velocity, and all we type down here is ref turn smooth velocity, and the function will handle the rest. And finally, we input our smooth time. So let's put in our turn smooth time. Now this function is definitely a bit weird, but it's a great way of smoothing numbers and particularly angles inside of Unity. So if we now put in our angle here instead of our target angle, we should see that when we move around, our player will smoothly turn from one side to the other. Awesome! Of course, we still need to have the player travel in the direction that our camera is facing. So to do that, we go into our script, and at the top here, we need a reference to our camera. Let's create a public transform. Let's call it cam. And now when we go ahead and calculate our target angle here, let's simply add on to that cam.eulerangles.y. And that's really all we need to do. We simply need to add the rotation of the camera on the y-axis on top of our angle. And this is of course going to have our player point the right way, but we still need to make sure that we also move in that direction. So instead of just using the direction here, let's go ahead and create a new vector3 called move direction. And let's set that equal to quaternion.euler 0 target angle, 0. And this is where a bit of knowledge of quaternions and vector math come in handy, because in order to turn this from a rotation into a direction, we can simply multiply our quaternion with vector3.forward. And that should give us the direction we want to move in, taking into account the rotation of our camera. And so let's just change direction here to move direction. And as always, when moving, we want to normalize this. And that is actually it for our script. If we save this now and go into Unity, we then need to reference our camera. And for this, use the main camera and not our third-person camera. Use the original main camera here. And with that, if we play and look in a certain direction and press forward, we can see that immediately our player starts to go in that direction. We can of course also go sideways relative to where we are facing and backwards. And so we have a nicely functioning third-person character with camera. Awesome. Now finally, one of the problems that you might see with the current way that we've set up the camera is that because we're able to kind of look everywhere, sometimes we might be able to look a place where we can't even see our player anymore. And if it gets really bad, we can maybe even move our camera inside of obstacles or parts of the level. Luckily, Cinemachine actually has a feature built in to help avoid this. So if we select our third-person camera and go to the bottom here, you can see that we can add extensions to our camera. And one of these extensions is the Cinemachine Collider. What this basically does is have our camera check if it's currently colliding with something, or if there's something in the way of our camera seeing our character, and then moves our camera out of the way. It's really easy for us to set up. We just want to select what layers we should check whether or not we're colliding with. So right here you can see it's currently set to default. Well, I've gone ahead and set all of my environment objects to use the ground layer. So in my case, I'm just going to go ahead and change that to ground and then remove default here. We're also going to have it ignore all player. So under ignore tag here, we can select player and then simply give our player that player tag. And finally, we want to set the strategy from preserve camera height to pull camera forward. This is the behavior that you want in most games. And what this basically does, if I go ahead and demonstrate here, is that if something gets in the way of us seeing our character, our camera simply moves forward. And if we collide with the obstacle itself, the same thing happens. You can see we cannot move our camera into this obstacle. Really, really cool. I find another thing that really works with this, if we go to the top, we can change the lens near clip plane to something smaller, which will just help increase our margin of error because we can get closer to an obstacle without our camera clipping through it. And finally, if you want, and this is completely up to you, you can add some damping to this. So we could go ahead and set this to something like 0.6 and 0.6. And what this will do is just smooth out the movement of our camera. This will mean that it sometimes travels through the object, but I find that this is actually an okay trade-off in most cases. That's completely up to you if you want to add that, but I find either way, this is just a great way for your camera not to constantly get stuck inside of other objects. Awesome! That's pretty much it for this video. If you enjoyed it, make sure to subscribe and ring that notification bell so you don't miss the next one. Now from here, it's up to you to start adding more features to your controller as you need them. If, for example, you want to add gravity and jumping to your controller, we'll of course have a link to our first-person controller tutorial where we show exactly how to do that. it should be pretty easy to just add to the script. Of course, creating a really extensive controller can take a lot of time and quickly becomes pretty complicated. So if you want, you can always pick up a third-person character controller on the Unity Asset Store. I personally recommend this one since it's fairly easy to get started with, and it has so many features like driving, sliding, ragdolls, a moving platform system, inverse kinematics, and the list goes on. We'll of course have a link to that in the description. Also, don't forget to check out Jason's course on game architecture. Learn how to properly make big games by simply clicking the link in the description and get a free hoodie included. On that, thanks for watching, and I'll see you in the next video. Thanks to all of the awesome Patreon supporters who donated in April, and a special thanks to Dash Black, Lost to Violence Stuff Forever, Face Amerify, John, Replica Studios, SRT Mike, Leo Lisette, Jason Yutescu, Nobby Ninja, Ville Vatanen, Daniel Desanic, Donachin Gascoigne, Dante Sam, Jacob Sanford, Naoki Wasaki, Marc-Antoine Girard, Gregory Pierce, Michael Korobov, The Mighty Zeus, Owen Cooper, Alison the Fierce, Erasmus, and Sirius. You guys rock.